Alright guys, so today what we're going to do is we're going to take some notes on adding and subtracting rational expressions. I would like you to follow along in your handout, and whatever I write down on the piece of paper you're going to also write down as well. Okay, if I'm adding, we go to old school, 1/3 plus 1/2. How do you add two fractions? You find the common denominator. Okay, the common denominator between the two is 6. So you would have to multiply one fraction by 2 and the other one by 3. And what you do to the bottom, you have to also do to the top. So you would end up with 2/6 plus 3/6. And what is 2 plus 3? 5/6. So that's your common denominator. Okay, we're going to do the same thing except we have some letters there. Okay, variables. If you look at number 1, are the denominators the same? Yes. So I can just subtract straight across. What's n minus 6 over w to the 5th power?
4.
10 minus 6 is 4, w to the 5th power, and then you're done. Okay, if you look at number 2, do they have a common denominator? No. So what is the common denominator? 30? So I'm going to have to multiply 6 times 5 and 5 times 6. Notice how they're switched, right? Whatever's on one fraction, you multiply times the other fraction. So your common denominator is 30. And whatever you do the numerator, you also have to do the denominator. So what's 4 times 5? 20k. And then in the first fraction, what's 6 times 7? 6 times 7 is 42. 42k. I'm going to zoom in a little bit, okay? Okay, what's 42,000 plus 20,000? 62k over 30. Okay, and then you always want to simplify. Once you're done adding or subtracting the two fractions, you want to simplify. So what can you reduce this fraction by? 2. 2. Good. Is that the highest you can reduce it by? Okay, what's 62 divided by 2? 31k. Good. And 30 divided by 2? 15. That is as low as you can go. Okay, that's as simple as possible. The numerator can be bigger. In this case, when I said 31,000, it's really just k.
Well, yeah, no, I get that, but 31 is bigger than 15.
Oh, I see what you're saying. Yeah, you can leave it like that. It's an improper fraction.
Yeah.
But you can leave it. You don't have to put it into a mixed fraction, which would be like 2 1/2 or 2 1/5 or whatever. Yes. Good question. All right, so let's look at number 3. What's the common denominator? 21. Good. How do you know that, Ben? 21. How do you know 21? Because you're smart, but other than being smart, what's your logic?
Okay, you found this 3 by 7 and 7 by 3.
Perfect. Okay, I want you to see the pattern that we're multiplying by the other fraction. Okay, whatever's in the denominator in 1, you're going to multiply the other fraction by that number. Okay, so 7 times 3 is 21. And what is 7 times 4?
28b.
28b. And then 5 times 3? 15b. Okay, now you have a common denominator of 21, so you can add the numerators. What is 28 plus 15? What is it? 43b over 21. Can this reduce?
No.
Yes,
That's as far as you can go, okay? Do you guys have any questions on that? Easy, right? Okay, let's go to a little bit more complicated. Now we're going to add and subtract with monomial denominators. Do you know what this word means?
One.
Yeah, with one in the denominator. And one term is really what it's talking about. All right, so first you're going to reduce the fractions, find the lowest common denominator, multiply to get a common denominator, and then add the numerators. Okay, so Christian, if you look at number 4, what is the common denominator? Okay, so notice how we have these letters added to it. Okay, so what we have to do is, can you reduce anything from the top or the bottom? No. So find the lowest common denominator. What you're going to do is you're going to multiply one side by 10a, and then you're going to multiply the other side by 5b. Okay, similar to how we did in number 2. You multiplied one side by 6, and you multiplied the other fraction by 5. Okay, so you switch them. So now you're going to have on the bottom 5b, times 10a, or 10a times 5b, doesn't matter. And then 5b times 10a. My denominators are the same, but now I have to multiply the numerator by 5b. So what's 9 times 5b? 45b. And then you have to multiply the numerator times 10a, which gives you 40a. Are my denominators the same? Yes, all I need to do is actually just combine these. So I'm going to have, most of the time, you want to put this in alphabetical order. So what comes first, A or B? A. So you're going to write 10a times 5b, and then on the top you would write 40a plus 45b. Since they're different letters, you know, they're from different gangs, they don't mix, right? I can't combine 40 and 45 because one is, I told you guys this already, right? One's a Crip and the other one's a Blood, so they don't mix. Okay, we gotta keep them separate. Make sense? Okay. West Coast, East Coast, you know, they don't get along either. Similar. All right, so let's look at number, oh, you know, rap started in the 90s. I think you guys were barely born. All right.
Where did you live?
Where did I live?
In the 80s, man.
Yeah, but hardcore, like fighting, and I'm gonna pause this. They're not common. One's 5b cubed and the other one's 3b squared. Right, you're going to multiply 3b squared by 5b cubed, and then you're going to multiply 5b cubed by 3b squared. So at the very bottom, I'm going to write, well, let me rewrite it. 3b squared times 5b cubed plus 3b squared times 5b cubed. Okay, it's the same denominator now, but what you do to the denominator, you have to do to the numerator. Okay, so what am I going to multiply together?
3b and 2.
Yep, 3b squared times 2 gives you 6b squared. Okay, good. And then on the second fraction, you're going to multiply 5b cubed times 4. 20b cubed. Okay, we have the same common denominator now, so I'm going to add these two together. Can I? Are they from the same family? So I'm going to leave them separate. So I really have 6b squared plus 20b cubed all over 3b squared times 5b cubed. Okay, and I would like you guys to do number 6. Yeah, 2y times 3x is your common denominator. So you're going to multiply both sides by the opposite, right? So I'm going to have 3x times 2y. And the only reason why I'm putting 3x first is because it's in alphabetical order. Okay? But it doesn't really matter whether you put 2y first because you're multiplying. It's the same thing. Okay? So what is 2y times negative 7xy? Negative 14xy squared. But this is a positive. So really it's 2 times negative 7 gives you negative 14. X times nothing gives you x, and y times y gives you y squared. On the second one, what's 3 times 4? 12x y squared. Perfect. Okay, and now that you have a common denominator, you're going to add negative 14xy squared plus 12xy squared. Actually, they're from different games. Okay, so this is an xy squared. This is an, oh wait. Oh, yes, you're right. Okay, so since they are from the same gang, sorry, I told some of you guys they weren't. My bad. So, you see how they're the same? xy squared, xy squared. So what's negative 14 plus 12? Yeah, negative 2xy squared over 3x times 2y. Well, actually, we're getting to one that we can continue simplifying. What's 3x times 2y? Yeah, we're multiplying, so it would be 6xy. Notice how it's similar to the top. So now you can cancel whatever is the same from the numerator and the denominator. You can simplify. Remember, this is back to what we were doing when we were breaking the code. You can get rid of the x's. You can get rid of the y's. And then can you reduce that fraction? Yeah, yours becomes negative 1y. Sorry, and I really ran out of space. Negative 1y over 6. Ah, my bad, 3. Okay, notice how this is a combination of everything that you've learned. We learned how to multiply expressions. You did that by getting the common denominator. You learned how to group things together and simplify, which we're doing as well. And then finally at the very end, we're dividing, or well, dividing the numerator by the denominator. Do you guys have any questions on this? You just need more practice, right? Okay. I think the bell's going to ring in a few minutes, so I'm going to go ahead and stop.